Be honest, you forgot your log properties, didn't you? Okay, not a big deal. Let's go ahead and refresh our memory. So here are three log properties that you really need to know. The first, natural log of a times b. We know that with multiplication of a term inside a log, we can split those up into two logs added. Note that all the logs have to have the same base. So here I'm using natural log. Natural logs have the same base, so it comes into one natural log. But if these have logs of different bases, they will not have this property. Second, we've got natural log of a over b. We know that division turns to a subtraction, so we get two logs subtracted from one another. Note that we can, of course, go backwards as well. So if you have two logs subtracted, we can just do one log with division. Last but not least, we have a log of something raised to a power. With this, we can actually take our power, our exponent, and we can drop it down in front, multiplied. So with those properties in mind, let's go ahead and look at a couple practice problems. So in this problem, we're given a function f of x, and we want to find its derivative. If we know a little bit about derivatives, we would have to apply a product rule and a quotient rule alongside some chain rules here. That's going to be really ugly, and so what we'll want to do instead is break this expression down using logarithms into simpler expressions. So we'll take the logarithm of this expression. Note you can use any log you want. I'm going to use natural log for simplicity, and what we get using our properties is ln x to the 5/3 plus, from the multiplication, ln of the cube root, minus, because of the division, natural log of 7x plus 8 to the 5. And what's left is to drop the exponents down using our third property. What we see is the 5/3 comes down 5/3 ln of x. This square root is a 1/2. That'll drop down 1/2 ln 3x squared minus 1. Last but not least, we have this 5 here. That'll come down minus 5 ln 7x plus 8. Now, the reason we did all this is because the derivative of this blob that we started with is rather complex to do, but the derivative of each of these simpler expressions is much easier to compute.